I'm here with my two vices. And I'm here to talk about targets and how they relate to Overwatch. So first, I need to discuss what is a target and why is it important for an empirical study of anything, but Overwatch as well. So if you and your friend were arguing over who was the faster runner between the two of you, you wouldn't just keep debating forever. You would have to go outside, draw a line, look at a tree, and then run to it and see who got there fastest, which would give you an empirical result, who arrived first. You might try different distances, repeated trials. Eventually, one of you would have to accept that at least on this day, one of you was indeed fastest. This acts as a basic target, which functions as an empirical basis for a conclusion, basically. So targets don't just have application for predicting dominance, which is one application potentially for them, but also they have the possibility to pick up causation or potentially at least correlation to some extent between things that occur and then the outcomes that result on average. So if you were to, for instance, try out different strides to keep our running analogy and different ways of running, you wouldn't just base it on, oh man, this really feels good. I think that this theoretically should be the best way to run. You wouldn't necessarily totally go on that. And if you were serious, what you would do is you'd say, well, let's try it both ways. Let's time it or something. And then you would go ahead and have an empirical basis for saying that at least at this current moment, this style is more likely to make me win the race later today than another. And in that way, it would be a basis for decision making and analysis as well as just purely determining who is the better runner. So what are the characteristics of a good target? So this little beautiful acronym here, UIIIF or UIIIF, it's definitely not entirely unique. In fact, none of it's totally unique. Although this creation and this presentation of it is in this case. So the first one is unbiased. So there should be as close to a direct relationship as possible. This is really clear in games that have a scoring system, like basketball, where if you were doing points, there would be a very clear and unbiased relationship between points scored and the ultimate thing you're trying to get at, which is victory. Because, well, if you have more points than the opponent at the end of the game, you win. As simple as that. If it wasn't a perfect match, then there would be some confusion around, for instance, if you were 2 points up, and then for some technical reason, there's a rule that says, oh, if you win the game 2 points up, then you actually lose. That would mean that points scored would lose a little bit of connection to that ultimate, the target that you're trying to, that you're associating it with, which is victory, which is your ultimate goal. So that is a problem, although basketball thankfully does not have it. This doesn't have to be a perfect relationship to be useful, but it should be reasonably close, or at least a strong predictor as possible for it to be useful. It should be incremental, ideally. So what this means is that each individual unit of the target should have equal value or approximately equal value. So for instance, it can, let's use basketball again. The last point of the game, some people disagree with this very strongly, I guess. They might watch the last 2 minutes and say, well, all that matters is do you get the winning shot? Well, that point at the end of the game is no more valuable towards victory than a similar shot, 20 minutes before. It doesn't have any additional significance. Every unit has the same value towards victory. It might not seem as exciting because there's still a lot of uncertainty at the time in which that happened about the outcome, but it has no additional value, and the fact that it's incremental in this way is very useful for analysis, because then we can treat those increments equally as well. Independence. So knowing about one portion of results for your target should not tell you overly much about other parts. Now, this doesn't account. This isn't including things like, for instance, the Patriots are really good at football. They got a point. Well, they're probably going to get more points as well in the future. But nothing about the mechanics of the game have changed for the future to give them a better or worse chance of getting future points. It might be what our expectation for the future is, but there's nothing actually in the mechanics of that game where that is more or less likely, particularly. Identical. So the fact that there's the same initial conditions at each one of the increments is very, very useful for it to be able to be studied. So this would fall apart in football, for instance, is after a segment coming back from a break, all the players just like ripped open like some steroid packs that is all injected in their arm, and they became like superhuman for the second for a stage. That would throw off the initial conditions that we have to adjust to the fact, oh, it was during that type of when they're on super steroid. That means that this type of performance means something different than it did before. And that this is important. And then lastly, frequent. And I don't mean necessarily frequent in actual time, but rather that there be very few actions that were possible, or at least a discrete, a manageable number of possible actions that could cause what we observe. So an example of something that would be reasonably discrete would be something like chess. There is a actual, at least for the next X moves, there is a discrete number of chess moves that could be made and counter moves to that can be analyzed and mapped out. When you start getting into things like in video games, in a lot of cases where there's real time and there's space with all the angles and all the abilities and timing of all these abilities and cooldowns, there are so many possibilities that anything that is over a pretty short period of time in the increment, it is going to result in it being very hard to narrow down and structure it in such a way that we can really feel good about our modeling of the situation, that we really understand what is happening relating to that target. So let us go to the ideal sport target, the beginning of Moneyball itself, for one very important reason, which is that it has an ideal target, which is that the entire game is people going up to bat and trying to hit a ball repeatedly. And because there's a finite number of ways that that could result from a particular at-bat, given the initial conditions of who's on what base and what is the strike count and things like that, and the current score of the game and what round of the game you're at, it's reasonably modelable out what the state of the game actually indicates for the scoring of the game. And it's unbiased in the sense that if you have a lot of successful batting rounds, that leads to people getting on base, which results in points, and the team with the highest points wins. So it's quite unbiased. It's very incremental, which is that you would be happy to trade around. I got points in the 6th inning. I got points in the third inning. You'd be perfectly fine trading those out. None of those points are particularly more valuable, just like any point game. They're independent, which is that maybe if someone does really good at pitching earlier, maybe they're going to be a little less good later because they get a little tired, but that's pretty trivial levels of dependence. If someone hits a home run last time someone goes at bat, does not make it more likely, other than maybe morale, for somebody to hit a home run this time. There's no direct connection there. They should be identical, and this is where baseball really comes into its own, because as being so beautiful from this perspective, because it's like an experiment. Every round starts exactly the same conditions, everyone's in the exact same place, and then it happens repeatedly over and over again with the exact same initial conditions. And it is frequent, which is also a very key portion of this as well, which is there's the throw, what kind of throw was it, and then the batter trying to hit it. And then the only things that really affect it other than that is, well, maybe the fielder, a couple fielders interact with it, and mostly that has the possibility to spoil the defense, where someone screws up and doesn't manage to do what they're supposed to do, or someone really overachieves. But those are more on the margins than just what the batter and pitcher relationship. Although I'm not an expert on baseball in any way. And then, so let's contrast that with a game that has very mediocre targets and therefore is a tough study of empirical analysis, which is League of Legends. So I'm going to go through two separate targets and give the problems with them that make them not ideal for the purposes of as an ideal target. So first, gold. So the good thing about gold is that it is a pretty good heuristic that the team with the most gold at the end of the game wins most of the time, or at least with a substantial difference of gold. If the gold is relatively close, then that rule isn't nearly as strong. But it's a pretty strong relationship, so that's something in its favor. Incremental. This is flawed because that 42nd thousandth gold that you got is not equivalent to the 5th to 6th thousandth gold you got in the proportional impact that it has on what it does for your team's strength relative to the opponent. If you get a 2k gold lead early in the game and then you hold just 2k gold till late game, it's going to feel like nothing. And if it was incremental, then you'd be perfectly happy to trade that 2,000 gold advantage to any point in the game, and it would be of equal value to you. And it is clearly not in League of Legends. Independence, another huge problem for League of Legends, is the fact that there's such a strong snowball mechanic to the game, which is that if you get an early lead, then that's very predictive of getting future leads because you're stronger and you're able to muscle out additional gains. So it is not independent. Identical, once again, rip. League of Legends, Ashe at the beginning of the games, as I kind of give the steroid example. Ashe at the end of the game is like early Ashe. It's an entirely different champion. And it would be utterly unfair to both to try to judge one with the other's metrics of success. And overall, gold is just a very ugly target for empirical analysis if you're trying to say what kind of actions are going to get me 2,000 gold and you're using data across the entire spectrum of the game. It is a ugly target because so much is changing, so much is dependent. Yeah, exactly. And then, so since we can't use gold and we don't have any other better metrics that I can think of, I'd be happy to hear suggestions. We can all agree on victory, though, because obviously, if you win, you win. That's what we want. The problem with victory is, although it's unbiased, it's a home run, it's incremental for very boring reasons, it's independent, it's identical for the most part, unless you're comparing between games where there's like a blue-red side advantage sometimes. Frequency, though. This is where things really fall apart because there's so many possible ways a game of League of Legends could play of a total different order of magnitude than the number of ways a chess game, for instance, could go, because one's a continuous type of spectrum and one's a more of a discrete nature, that it would be an unbreakable barrier just to look at the end results of a League of Legends game and attempt to model the game so completely that you would have a good sense for what was the causal relationships there. And as I elegantly put here, it's so complex that until we have the wisdom of gods and computer power to drain the sun of its energy, we will likely not be able to definitively try to answer questions like, should I trade 50 gold in minions to poke my lane opponent at 4 minutes? You're not going to be able to evaluate those benefits and costs effectively in a way that both is sound and also which is causal in nature on that basis, those types of questions. Or even less specific questions. It would be very difficult. Maybe some very fundamental ones like lane assignments and something like that. You might be able to come up with some answers. So let's move into Overwatch, finally. So there are 3 layers of targets, each kind of arising from the previous one that I have kind of prepared. So first, there's victory, which is the same kind of example of League of Legends. So you can always use victory and loss. There is the time each team spends accomplishing objectives. So this is, I think, the unit of Overwatch for winning, because it's the amount of time that you have on the payload uncontested, which moves it. There's the time completing a point. There's the ticking up of the meter in control. All of these things are about time being uncontested, accomplishing an objective. And then there is fights. So what allows a team to be uncontested and achieve dominance to accomplish objectives? Well, they have to win a fight to gain dominance. So fights itself is a kind of second degree predictor of victory. I'll also, since this is more specific to Overwatch and our current limitations, I'm going to discuss technical concerns as well, potentially through here. So first, for victory, similarly, you can use victory, but just like League, although not quite as bad in my view, because the games are shorter and more structured in some ways. There's not items, for instance. It is still there's so many individual components to it that it is impractical to attempt to model an entire game of Overwatch in a sophisticated and complete enough manner to be able to identify what every decision's component and execution had on victory. Second, you can look at accomplishment of objectives. So it is unbiased because you're accomplishing objectives in a linear fashion. Either you are pushing it forward or you're not pushing it forward. Either you're ticking it up or you're not. And the team with the most of that unit of time of doing that wins. It's incremental because I would trade a successful 5-second push earlier in the game versus later in the game, unless you're dealing with the tricky times like around the running out of time to be able to push to the next. But that's on the margins. Overall, on average, it's pretty incremental. Overwatch does have some independence issues, although not nearly as strong, for instance, as League, but still something to deal with, which is that there are snowball mechanics and anti-snowball mechanics in it, which is that if you succeed in this fight, you'll gain ult charge, and you might have an advantage next fight as well. So in that way, accomplishment is correlated, because if you accomplish a bit now, then it might make you more likely to accomplish a bit later. But this dependence is pretty short-lived. If you were trying to predict what are you likely to win the fight after the 3-minute mark from now, like you'd have a difficult time coming to a good conclusion on that because the dependence is pretty short-lived. There's so much that can change. Identical. One good thing about Overwatch is that there is no scaling of champions. There are differences because you have ultimate or you don't have ultimate, and there's some positioning differences, I suppose. But overall, like those things come, they go, they're of reasonable proportion, and because there's a finite number of different initial stages that are manageable, it's not too terrible, and they're frequent. Since dominance is a measure of time, it's clearly frequent because it's in real time. Either you're achieving the goal or you're not achieving the goal at any given moment, and you can evaluate whether certain actions lead to immediately achieving goals or not. The downfall of accomplishment is the fact that there are multiple map types. So accomplishment acts very different in control than it does in 2CP, which acts very different than in a payload map. While in a payload map, a unit of control you might have a ton of time of control because you're pushing a payload and continuously, and it's more on your turf more of the time, farther away from spawn, and the dynamics of that relationship is much more in favor of more time controlling the objective. While in 2CP, any amount of actual control time results in victory. So like comparing those is you'd have to massively adjust the scales to make them comparable. And then so it makes it a slightly unideal target unless we were going to analyze a specific map type only, in which case it could be workable as a target. And then lastly, there is fights. Now, how does one get accomplishment? Well, you have to get dominance for a period of time, and you do that by winning fights. Now, our definition for a fight in Overwatch is a bit arbitrary, not perfectly set, but it's basically the team that has the most kills in a fight is the winner. If it's the same number of kills, it's considered a tie. If there's no kills for 15 seconds, then that considered the separation of fights, which matches pretty nicely with respawn times and the time to get back into a new fight. And so through this, and the advantage of this metric is that it is similar across map types. So while the mechanics of accomplishment might be different between payload and 2CP, the ideas of winning a fight, accomplishing, or giving you the chance of accomplishment should be relatively similar, or at least more similar than the accomplishment metrics. So let's go through the individual components. So for unbiased, this is a little bit sketchy because technically winning fights does not win you games. Accomplishment does. But a fight on average should give you a certain amount of accomplishment because you have gained dominance in such a way that you're going to not be having any kills happening in the future, and you have more people than them, and they're not going to be able to contest you. So if you're the attacking team, you're going to be able to push the objective for the amount of time until they regroup and set up for an additional defense. If you're on defense and you win a fight, well, that's a opportunity cost where they could have won the fight and pushed it farther, which means you would have had to push it farther on your attack. So overall, this is a pretty consistent metric. And while if things are close, Maybe you could be 1 fight up and still lose. Maybe you could even be 2 fights up and still lose. But overall, this is relatively proportional to that time of accomplishment that we discussed above. And I will, since this is me, you kind of taking this on faith, that's actually going to be something that I go over in some code in just a second to give an idea of that relationship. Since it's really the linchpin of this being a valid and my recommended target for Overwatch. So it is incremental, similar to accomplishment, because you'd be just as happy to win a fight later in a game and get that associated accomplishment than earlier. They're independent in the sense that relatively independent, I should say. They're not independent, but just like above, there's some differences in ultimate and positionings, but those things roll back and forth, and there's not broad dependence throughout an entire map of Overwatch of the conditions. And identical because they're not too bad. There's not too many different initial conditions that this is workable, and they're not as dramatically different as a like a level 1 Ash and a level 18 Ash with full items, for instance. Not nearly to that extent, and the differences are well within the range of being modelable. And then lastly, frequent. So they are pretty frequent because they happen every 30 seconds or so. Most of the things that aren't happening in a fight just aren't that important because you're not fighting anyone, you're just setting up positions. So fights happen regularly, and the good thing is that due to the mechanics of man advantages in fights in Overwatch, the actual time from the beginning to the fight basically being over for all intents and purposes is actually pretty short, which is ideal because there's not that many actions that occur during that interval, which makes it studyable because once you gain a certain degree of man advantage, the fight is pretty well determined. So let's go ahead and jump over into this code I have written ahead of time to demonstrate this. Pop open my R console. Okay. So the first one I'm going to look at is fight differential per minute. So what this is getting at is saying is if you get 6 kills, let me do a thing. You get 6 kills and your opponent gets 4 kills, and this is in 10 minutes. That's 10 total. Sorry, 6 fights you win and 4 fights your opponent win, and it's in 10 minutes. You've gotten 2 fights up on them. And how long did it take? 10 minutes. So that's 1/5 fight per minute that you are actually managing to get up on your opponent. So here what I did is I plotted just a approximate averaging plot of the various types of maps and the associated win percentage for the map by various degrees of dominance of fight. So if you'll see if team 1 is down, they lose a lot of the time. If they're up, they win a lot of the time. And overall, this functions pretty well across Assault, Escort, and Hybrid especially. It is directionally right for Control, but it is weaker. I believe the reason it is weaker for Control is because when you are attacking, when you're basically effectively acting as the defender, attempting to stop your opponent from gaining objective time, and you are still contesting them, they're still getting percentage until you capture the point back. Well, that is not how it works in other game modes, which I think weakens the relationship between fight outcomes and the map outcomes to a pretty significant degree, which is why one of the reasons why getting that first point is so important, because no one is getting any percentage during that time. So if you win the first map, first fight, and then you take control of the point, if the opponent takes that point back from you by winning a fight, you're going to end up with more cumulative percentage because during the process of the fight, you're gaining percentage. So what I've done is I went ahead and flipped it around so that always it's a positive number. So the team that's ahead is on the x-axis, how much are you ahead, and then the chance of winning for that team that is ahead. Because team one and team two in my data set, which I got from Winston's Labs on public data, I think starting sometime, I think on the 7th of March, because there were some uh, changes in the way the database was handling it, so I threw away those to be consistent. But overall, we can see that that control is significantly slower, where you can have larger differences in fight outcomes and still have a victory, while it pretty quickly converges to if you have 1/10 of a fight. So if you're gaining one fight every 10 minutes ahead of your opponent, which isn't tremendously much, then the game outcome is pretty clear. And if you get up to 2 fights, or even like 0.15 or so fights per 10 minutes, 1.5 fights per 10 minutes or something, the game it becomes very close to a determinative relationship, which is quite nice and verifies the fact that since it is approximately proportional to accomplishment, there really aren't many ways you can be losing a lot more fights than your opponents, and somehow denying them the ability to get accomplishment. And you're not likely to get accomplishment yourself very well unless you're winning fights as well. So just to give some actual raw data to this, here's a quick little actual thing with some real numbers instead of this approximation through visualization. So you'll see that for assault, by the time you get up to about 17.17 fight differential per minute, you're already up in the 98% chance of winning range or so. And these are the number of maps. This is the number of minutes represented of play time in our database. And so you'll see that by the time you even get up to above 1 fight per 10, it really starts getting high for assault. For escort as well, by the time you get above 0.1, the relationship becomes almost determinative. A lot of the reason why it might not be determinative in some of these cases is actually because the way that we're capturing fights might be wrong. So I would suspect that the true number for, like, if we were going through by hand and evaluating what was a fight and who actually won the fight by determining who got control of what they won afterwards, that these numbers would be even higher, that this would be even a steeper curve, and that with a better API we may be able to improve our definition of a fight even more based on other metrics like damage and other activity of when activity is really happening. And you can see that for hybrid the same thing holds. Control is the ugly stepchild, where even through pretty significant disparities in fight outcomes, there still is some pretty real variability. Note that this is control on a submap basis and not on a map basis, since there is a full reset. If you're looking at the combination of 3 different maps, then the relationship would fall apart because how strong you beat them on the first control submap does not carry over to the second one. While in hybrid, if on attack you destroy them entirely, that means they have a bar to meet. It does have an impact that carries over. Okay. So something, another way you can look at this is fight win percentage. So fight win percentage, I'm just going to go ahead and go to the second plot. So something that might be more familiar to that Carahall has been plotting, and I'm not sure if he prefers it or if it's the fact that he just hasn't looked at it in the way that I have. I personally prefer fight differential per 10 minute because I see it as relating more to actual push distance, while fight percentage, you have to give a lot more information to actually know what that means in terms of like how much difference of objective time really should that equate to. And you'll see a similar curve, which is that both of them rise quite steeply. And let's go ahead and show the plot. Oh, got to actually expand this, otherwise it's going to fold over. Okay. So quickly, you'll see that if you have anything higher than a pretty low fight percentage win rate, it gets up into the nice 90s, close to causal. And if you get really high percentage win rate, well, there's basically no imaginable scenario where you could lose. Control, once again, is a little bit slower, but it's actually slightly better as fight percentage. And then escort, similar pattern. Hybrid, similar pattern. So you'll see that it's a quite strong relationship that holds across map modes, which is one advantage of it over some kind of time of accomplishment type metric, which would be expected to vary quite a bit different between map modes in relationship to victory. So that has been it for today. I'd appreciate any feedback that there are. This is going to be something that we look at heavily and try to improve and start to bring into our analytics. I think one of the things that's caused some fuzziness in the Overwatch community around statistics is the fact that it seems so wishy-washy a little bit, where it's like while we all can agree that getting more kills is a good thing, it isn't particularly useful in an empirical way to be able to say to answer questions like, would it be better to get 2 more kills for 1 extra death? Would it be better to, in various situations, empirically for evaluation, other than get more of the good stuff and less of the bad? It doesn't do well to resolve our differences that people might inherently have between the figurative, like who's a faster runner between 2 players, because so much is subjective and not tied to an agreed upon target of a measuring stick to judge teams by and actions by. So I think that as we improve and try to bring this in the future, that it will potentially make it stronger and more applicable both to you plebs out there and also teams that are working with statistics in Overwatch, and hopefully it can come to some practical use.